If you wear glasses or contact lenses, take them off right now. Look around your room. Notice how the sharp edges of your world instantly melt into soft, blurry shapes. The clock on your wall becomes an unreadable smudge. The books on your shelf turn into featureless blocks of color. If you drop your glasses on the living room rug today, it is a mild 5-minute inconvenience. But in the Pleistocene epoch, losing your vision wasn't an inconvenience. It was an immediate ticket to the bottom of the food chain. Imagine standing in the tall grass of the African savanna 40,000 years ago. The sun is setting, casting long, dark shadows across the plains. In the distance, 20 meters away, you spot a dark, blurry shape crouching behind a bush. Is that blurry shape just a harmless, dry shrub swaying in the wind? Or is it a 300-kilogram cave lion preparing to pounce? You squint. You rub your eyes. But without a pair of plastic lenses perched on your nose, you literally cannot tell the difference between a harmless plant and a deadly predator until its sharp fangs are sinking into your throat. In the brutal arena of natural selection, bad eyesight is not just a physical defect. It should have been a swift and merciless death sentence. An eagle with blurry vision starves to death because it cannot spot a rabbit in the grass. A gazelle with poor eyesight is eaten first by cheetahs. On a planet governed by the cold law of survival of the fittest, any genetic mutation that makes an animal's vision blurry should be wiped out of the gene pool within a single generation. Yet, here is the mind-bending mystery that confounds evolutionary biologists. Today, over 40% of the global population suffers from myopia, or nearsightedness. In parts of East Asia, that number reaches an astonishing 80 to 90%. And genetic sequencing proves that the genes responsible for poor vision haven't just popped up recently. They have been passed down through human DNA for tens of thousands of years. How did our ancient ancestors with terrible vision manage to survive in a world filled with apex predators? Why didn't natural selection eliminate people who couldn't see past their own nose? The answer reveals one of the greatest secrets of human evolution. Our species did not conquer the planet by breeding flawless biological supersoldiers. Instead, we survived because we unlocked a secret superpower hidden inside poor eyesight. A superpower that transformed our weakest members into the most valuable masters of the tribe. To solve this ancient detective story, we first have to understand what natural selection actually cares about. When we think of early humans, we tend to picture muscular, razor-sharp-eyed hunters sprinting through the wilderness, tracking game over vast horizons. And for a long time, scientists assumed that any early human who couldn't spot a mammoth at 200 yards was simply evolutionary dead weight. If a tribe consisted purely of lone wolves, that would be true. If every individual had to hunt their own food, defend their own cave, and spot their own predators, anyone with -5 vision would have been eliminated immediately. But humans never lived as lone wolves. We evolved as hyper-cooperative social bands under a principle known as visual niche specialization. In a human tribe, survival was never about individual perfection. It was about division of labor. While tall, clear-sighted hunters scanned the distant horizon for movement, the tribe needed something else equally critical for survival: precision craftsmanship. Think about the technological explosion of the Upper Paleolithic era, about 40,000 years ago. Human technology shifted from clumsy hand axes to revolutionary micro-tools. At archaeological sites like Sungir in Eurasia, researchers uncovered burials of Upper Paleolithic humans wearing tailored leather garments adorned with over 3,000 hand-carved mammoth ivory beads. Each tiny bead required hours of painstaking microscopic carving. They crafted microliths, tiny, razor-sharp geometric flint blades less than a centimeter long, designed to be embedded into wooden spears. They carved delicate bone needles with microscopic eyes, threading thin animal sinew to sew airtight, waterproof leather clothing. They etched intricate, hyper-detailed animal art onto cave walls in total darkness by the dim, flickering light of animal fat lamps. Try doing any of that if your eyes are tuned exclusively for distant horizons. This is where the biological miracle of myopia comes in. A nearsighted eye suffers from axial elongation. The eyeball is physically longer than a normal eye. Because light focuses in front of the retina rather than directly on it, distant objects appear blurry. But close up, At a distance of 10 to 15 centimeters, a myopic eye acts like a built-in biological magnifying glass. While an eagle-eyed hunter sees the world at 1-to-1 scale, a nearsighted person sees microscopic detail with extraordinary clarity. They can detect microscopic stress fractures in a flint core before striking it. They can guide a bone needle through thick fur without tearing the hide. They can carve fine ivory beads and craft delicate fish hooks that clear-sighted people would struggle to even hold without dropping. In an ancient hunter-gatherer band, a nearsighted individual wasn't a useless hunter who got left behind to die. They were the master artisan. While the hunters brought home meat, the myopic craftspeople created the warm clothing, the deadly barbed spear points, the fishnets, and the ceremonial ornaments that kept the entire tribe alive through brutal Ice Age winters. The tribe protected them, shared meat with them, and valued their wisdom. And because they survived and prospered inside the warm, protective circle of the tribe, they passed their genes on to the next generation. This brings us to a second evolutionary surprise: age-related farsightedness, or presbyopia. As humans age, the ciliary muscles and lenses of our eyes naturally stiffen. By the time a person reaches their late 30s or 40s, focusing on close objects becomes difficult, while distant objects remain crystal clear. In modern society, we buy reading glasses and complain about getting old. But in the Pleistocene, this vision shift served a crucial evolutionary purpose. Older members of the tribe, the elders and grandmothers, were rarely out on the front lines of energetic hunts. Instead, they stayed near the camp, minding children, keeping watch, and processing gathered foods. Their aging, far-sighted eyes made them the ultimate sentinels. From a seated position near the fire, an elder could spot the faint movement of a stalking hyena or rival tribe member on the distant ridge long before a younger, near-focused gatherer even looked up. Human bands didn't just tolerate different types of vision, they depended on them. Diversity of eyesight created an optical mosaic that protected the tribe from every angle, near and far. But if poor vision was a useful specialization in ancient times, why is myopia suddenly exploding today into a worldwide epidemic? Today, rates of nearsightedness are skyrocketing across the globe. Clearly, our DNA hasn't mutated that fast in 50 years. So what changed? Groundbreaking research, including the famous Sydney myopia study led by Professor Ian Morgan, revealed the physiological trigger behind eye growth. Your eye is not born fully grown. During childhood, the eyeball constantly adjusts its shape to ensure light focuses precisely on the retina. How does the eye know when to stop growing? It turns out the stop signal is driven by dopamine, a neurotransmitter released by specialized cells in the retina. And the primary trigger for retinal dopamine release is intense natural sunlight. When children spend hours outdoors playing under bright sunlight, which reaches up to 100,000 lux on a clear day, retinal dopamine floods the eye, signaling it to halt axial elongation. The eyeball locks into a perfect, healthy sphere. However, modern industrial civilization locked children indoors under ambient artificial lighting that rarely exceeds 300 to 500 lux. Combined with spending hours staring at smartphone screens and books inches from their face, the retina receives zero dopamine stop signals. The eyeball assumes it is living in a dark cave environment where microfocus is required, stretching longer and longer into permanent myopia. Our ancient ancestors spent their entire childhoods under the open sky of the savanna. Even if they carried genetic predispositions for myopia, bright daily sunlight kept their eyes physically healthy, limiting extreme nearsightedness to a natural, functional minority of master craftsmen. When you step back and look at the whole story of human eyesight, it leaves you with a profound realization about what makes us human. If you look at the animal kingdom, every species is built around individual physical competence. A lion must be a strong runner, a falcon must have perfect vision, a wolf must have an infallible sense of smell. Any individual animal that falls short of its species' physical standard is ruthlessly culled by nature. Humans are the only creatures on Earth that broke this rule. We did not survive by turning every individual into an identical, flawless biological weapon. We survived because we learned to embrace individual differences and protect one another. Now, put your glasses or contact lenses back on. Look at the sharp, vivid world around you. Those lenses resting on your nose are not a symbol of your biological weakness. They are a crystal monument to the greatest triumph of human nature. The fact that you are standing here today, seeing this world in crystal clarity, is living proof that 40,000 years ago, your ancestors belonged to a tribe that chose empathy over elimination, protecting the quiet craftspeople whose blurry eyes helped build humanity's future.